Welcome to Noun Tutorial TV. Like, share and subscribe. STT205 Statistics for Management Sciences I Summary. Dash can be defined as a management tool for making decision. Statistics. Statistics is a management tool for making decision. Dash is a scientific approach to presentation of numerical information in such a way that one will have a maximum understanding of the reality represented by such information. Statistics. Dash is defined as the presentation of facts in numerical forms. Statistics. Statistics is defined as the presentation of dash in numerical forms. Facts. Statistics is defined as the presentation of facts in dash forms. Numerical. Dash is a scientific method which is used for collecting, summarizing, classifying, analyzing, and presenting information in such a way that we can have thorough understanding of the reality the information represents. Statistics. Statistics are concerned with dash data. Numerical. The roles of statistics include the following. Government uses statistics as a tool for collecting data on economic aggregates such as national income, savings, consumption, and gross national product. Government uses statistics to measure the effects of external factors on its policies and to assess the trends in the economy so that it can plan future policies. Government uses statistics during census. Business uses statistics to monitor the various changes in the national economy for the various budget decisions. Business makes use of statistics in production, marketing, administration, and in personnel management. Statistics is used extensively to control and analyze stock levels such as minimum, maximum, and reorder levels. It is used by business in market research to determine the acceptability of a product that will be demanded at various prices by a given population in a geographical area. Dash may be person, place, and thing on which we make observations. Entity. Dash is a characteristic that assumes different values for different entities. Variable. Dash is a variable whose values are given as numerical quantities. Quantitative variable. Dash is a variable that is not measurable in numerical form or that cannot be counted. Qualitative variable. Dash is the variable that can only assume whole numbers. Discrete variable. Dash is a variable that can assume both decimal and non-decimal values. Continuous variable. Dash is the largest number of entities in a study. Population. Dash is the part of the population that is selected for a study. Sample. Dash is a sample drawn from a population in such a way that the results of its analysis may be used to generalize about the population from which it was drawn. Random sample. Dash are data collected by or on behalf of the person or people who are going to make use of the data. Primary data. Dash is the data collected specifically for a purpose and used for the purpose for which they are collected. Primary data. Examples of primary data are, heights and weights of students collected to determine their nutritional well-being. 2. The population of primary school pupils in the states of the country to allow the federal government plan for the primary education. 2. The academic performance of students in secondary schools under various types of leaders to know the leadership style suitable for the secondary schools. Dash is the data that is used by a person or people other than the person or people by whom or for whom the data was collected. Secondary data. Dash are the data collected for some other purpose, frequently for administrative reasons, and used for the purpose for which they were not collected. Secondary data. Examples of secondary data include, accident fatalities on a particular road over a period of time collected from the police or road safety corps. 2. Dietary requirements of various age groups collected from a nutrition textbook. 3. Age distribution in Nigeria collected from the publications of the National Population Census. Secondary data have the following advantages. They are very inexpensive to collect since they are readily and abundantly available in published sources. 2. There is a great variety of secondary data on a wide range of subjects. 3. Many of these data have been collected for many years, hence we can use them to establish trends for forecasting. The information produced by the firms and private organizations, when monitoring the activities of their businesses, is called microstatistical information. In the concern is for the household and firm. Microeconomics. Information are produced by the public sector of the economy. Macrostatistical. The methods of data collection include surveys, observations, interviewing, questionnaire. The collection of primary data involves survey or inquiry of one type or the other. Examples of surveys are: I. Government survey. 2. Market research surveys, carried out for one particular client and not published in any form. 3. Research surveys, carried out by academicians and published in journals. 4. Firms commission ad hoc surveys on a wide variety of subjects. Survey methods consist of the following stages. 2. The pilot survey. 3. Collection of information. 4. Coding. Tabulation. 6. Secondary statistics. 7. Reports. The survey design. Is the methods of collecting primary data used to know the use of a particular facility. Observation. The following are the types of observation: participant observation, systematic observation, mechanical observation. Generally, observation has the following problems: objectivity, selectivity, interpretation, chance, participation. Is a conversation with a purpose. Interviewing. The formal interview is initiated by the who approaches the person he is interested in interviewing. Interviewer. Interviews are used in a number of situations that include: I. Obtaining opinion polls for the success of a candidate in an election. 2. Studying why people behave in a way. 3. Selecting applicants for some jobs. 3. Reporting, especially in the radio and television. Interviewing method has a number of advantages. It allows the interviewer to have personal contact with the respondents, therefore allowing more questions to be asked, which improves the quality of the information. 2. It allows the interviewer to persuade unwilling respondents. 4. It allows experienced interviewer to know when to make calls and recalls. Interviewing method also has a number of disadvantages. Biased interviewer may influence the responses of the respondents to suit his own opinions. 2. A biased respondent, in a matter affecting ego, may give false responses. 3. It is very expensive and time-consuming, especially when respondents are widely scattered. 3. It may be difficult to interview some top people in government and business. Is a list of questions drawn in such a way that the questions are related to the objectives of the study being conducted, and the responses to the question will be analyzed to provide solutions to the problems we attempt to solve in the study. Questionnaire. There are two types of questionnaire, namely, structured or fixed response questionnaire. 2. Unstructured or open-ended questionnaire. An example of a structured question is this: what is your monthly salary? Below N7500, N7500, and 10,000, and 10, 000, and 12, 500, above N12, 500. The advantages of structured questionnaire: it is very easy to complete and analyze. 2. Most of the questions are answered. 3. The responses are always related to the objectives of the study. The unstructured questionnaire has the following disadvantages. It is not easy to complete and analyze. 2. Many of the responses supplied by the respondents may not be related to the objectives of the study. 3. The respondents may not answer all questions, especially those considered difficult by them. The following must be considered in drawing a standard questionnaire. List all the questions you want to ask. 2. Decide whether to use direct or indirect questions or both. 3. A question must be limited to an idea. V. Ask simple and interesting questions before the difficult and uninteresting ones. V. State the questions clearly. 6. A question must mean the same thing to all the respondents. 7. The language must be at the level of the respondents. 8. Do not ask questions that will hurt your respondent. 9. The questionnaire should be pre-tested on a mock audience before it is administered on the real sample. Ordered array. When data are collected, they are collected in such a way that there is no particular arrangement of the values. This unordered array of values does not facilitate the process of analyzing the data. The data must therefore be arranged either in ascending or descending order of magnitude so as to facilitate the analysis. Example 3.1, suppose the ages of 20 pupils in a primary school are as follows, age to the nearest years: 6, 8, 10, 11, 7, 5, 8, 9, 11, 12. 11, 9, 8, 12, 5, 6, 10, 8, 7, 9. A look through the values shows no order of arrangement. An ordered form of the values shows the following: 5, 5, 6, 6, 7, 7, 8, 8, 8, 8, 9, 9, 9, 10, 10, 11, 11, 11, 12, 12. The data arranged in this form has a number of advantages over the raw data. I. We can quickly know the lowest and highest values in the data. 2. We can easily divide the data into sections. 3. We can see whether any value appears more than once in the array. 4. We can observe the distance between succeeding values in the data. A dash is a table showing the values of the data and the number of occurrence of each of the values. Frequency distribution. Example 3.2. For the data in exercise 3.1 above, present the frequency distribution for the values. The values will be represented by xi and the frequency is represented by phi. This table shows the values of the variable and their respective frequencies. Frequency distribution of group data. For many of sophisticated analyses, we need to group the data before analysis commences. We therefore group the data into class intervals. Class intervals are defined as contiguous, non-overlapping intervals selected in such a way that they are mutually exclusive and collectively exhaustive. They are mutually exclusive in the sense that a value is placed in one and only one class interval. The class intervals could be 5 to 9, 10 to 14, 15 to 19, 20 to 24. It could also be 11 to 20, 21 to 30, 31-40. I. Class limit. For any class interval, there are two class limits, the lower and upper class limits. For the example 3.2, the lower class limits are 11, 21, 31, 41, 51, 61, 71, 81. The upper class limits are 20, 30, 40, 50, 60, 70, 80, and 90. The dash of a class interval is the mean of the lower class limit of the interval and the upper limit of the preceding interval. Lower class boundary. 2. Class boundaries. For any class interval, there are two class boundaries. The lower class limit of the class interval is 11 and the upper class limit of the preceding class interval is supposed to be 10. The lower class boundary of the class interval is therefore. For the example 3.2, the lower class boundaries of the class intervals are 10.5, 20.5, 30.5, 40.5, 50.5, 60.5, 70.5, and 80.5. For the example, the upper class boundaries of the class intervals are respectively 20.5, 30.5, 40.5, 50.5, 60.5, 70.5, 80.5, and 90.5. From these values, you will see that the upper class boundary of a class interval is the lower class boundary of the succeeding class interval. The classes can also be given in terms of class boundaries rather than class limits. For example 3.2, if the class boundaries are used, we will have the following as our frequency distribution. 3. Class width. This is the difference between the upper and lower class boundaries, not class limits. For our example 3.2, the class width for all the class intervals is 10. For the first interval, the class width is 20.5 to 10.5. Equals 10. It is not 20 to 11. Dash is the mean of the upper and the lower class boundaries. Class mark. For example 3.2, the class mark for the first interval is. For the classes in the example 3.2, we have the following as class width for the respective class intervals 15.5, 25.5, 35.5, 45.5, 55.5, 65.5, 75.5, and 85.5. There is need to summarize what we have done so far into class limits, class boundaries, class marks, and class width. The dash of a value is defined by the total frequencies of all the values contained in the set of values. Relative frequency. Relative frequency on group data. Example 3.3. Suppose the frequency distribution of the scores of the 20 students in a test is as presented below. The total frequency is 20. The relative frequency of the first score is given as 1/20 equals 0.05. The relative frequency distribution of the scores is therefore given as group data. For the group data, the relative frequency of a class interval is the frequency of the interval divided by the total frequencies of all class intervals. For example 3.2, the relative frequency distribution of the class intervals is as presented. Relative frequency distribution of group data. The dash of a value is the cumulative frequency of the values divided by the total frequency of the values contained in the array of data. Cumulative relative frequency. Cumulative relative frequency distribution on group data. To construct the cumulative relative frequency, we need to construct the cumulative frequency for the data. For the example 3.3, the cumulative frequency and the cumulative relative frequency for the set of data is as presented below. Group data. The cumulative frequency of group data is constructed the same way as that of ungrouped data. Example 3.4. The table below shows the frequency distribution of the ages of employees in a firm. Prepare the cumulative frequency and the cumulative relative frequency for the ages of the employees. The cumulative frequency and the cumulative relative frequency distributions are as follows. Histogram. One of the ways of representing a frequency distribution is by means of a histogram. In constructing a histogram, we plot the frequencies of the class intervals against the class boundaries, not the class limit. The vertical axis is used for the frequencies and the horizontal axis for the class boundaries. Example 4.1. Suppose the table below shows the distribution of 50 spectators in a secondary school sports competition. You are required to represent the data with a histogram. NB. In solving the exercise, you require a graph sheet. You also need to prepare the class boundaries for the class intervals. You will then plot the frequency against the respective class boundaries. You still need to recall how the class boundaries are computed in Unit 3. The dash can be used to estimate the mode of the distribution. Histogram. The histogram can be used to estimate the dash of the distribution. Mode. Frequency polygon. Another way of representing frequency distribution graphically is by the means of a frequency polygon. In constructing a frequency polygon, we plot the frequency against the class marks. Example 4.2. Construct a frequency polygon for the data in example 4.1. To construct the frequency polygon, you need to compute the class mark for the class intervals. You need to make the polygon touch the horizontal at both ends. To do this, you have to compute the class mark for an imaginary class interval at the beginning and another imaginary class interval at the end of the distribution. Ochiv. This is another way of representing frequency distribution graphically. The other name for ogive is cumulative frequency distribution curve. This curve is very important in the determination of median, quartiles, percentiles, and semi-interquartile range. In plotting ogive for a distribution, you will do the following. A. Compute the upper class boundaries of all the classes including that of an imaginary class at the beginning of the distribution. B. Prepare a cumulative frequency distribution for the data. C. Plot the cumulative frequency against the upper class boundary. Example 4.3. For Table 4. L. Construct an ogive for that distribution. You will realize that the class interval 5 to 9 was introduced. A frequency of 0 was also assigned to the class interval since the original table did not show the class. This is done so that the ogive can take its origin from the horizontal line. From the table you will see that all the values that are less than 24.5 are contained Jn class interval 5 to 9, 10 to 14, 15 to 19, and 20 to 24. The sum of the values which is equal to the cumulative frequency of the interval is 0 plus 2 plus 3 plus 5 equals 10. Bar chart. A dash shows vertical bars with equal width to represent the values of a variable in some intervals of time. Bar chart. Simple bar chart. The area of the bar is proportional to the magnitude of the quantity it represents. The bars must be drawn on graph sheet and they must have equal width. There are simple components and multiple bar charts. In a simple bar chart, we use the bars to represent the value of a variable in a period of time. Example 4.4. Suppose the monthly sales of a firm for 3 consecutive months are given as follows. You are required to represent the data on a simple bar chart. Component bar charts. Another bar chart that shows the total value for a time period and the values of the components that make up the total is the component bar chart. In this case, the bar for the total value for a period is divided into the values for the components that make up the total. Example 4.5. Suppose a hotel has 3 departments A, B, C from where sales are made and the annual records of the net profit of the department S for 3 consecutive years are as presented below. You are to represent the values of the net profits with the aid of a component bar chart. You will need to plot the values of the components A, B, and C for 3 years. The first year will show a bar of length 9.4 centimeters divided into 3.2 centimeters for A, 3.4 centimeters for B, and 2.8 centimeters for C. You will then repeat the exercise for the values of A, B and C in years 2000 and 2001. There must be a legend to show the shading of the component. Figure 4.5, component bar chart for example 4.5. Multiple bar chart. For the multiple bar chart, each component of every year is presented by a bar whose length is corresponding to the value of the component. Example 4.6. Using the values of net profit in example 4.5, construct a multiple bar chart for the hotel for the period 3 years. In this exercise, you will draw single bar for each component of every year. The bars for a year will now look like histogram. Figure 4.6, multiple bar chart for example 4.6. Pie chart. In the case of pie chart, the sectorial angles are computed for the items based on their values and on the total values of the items. After obtaining the sectorial angles for the items, we use a pair of compasses, a pencil, protector, and ruler to draw the angles of the sector. Example 4.7. Suppose the monthly income of a worker is allocated as follows. The total values of the items is N27, 500. This is to say that the monthly income of the worker is N27, 500. 360 degrees is used in the calculation because the sum of angles at a point is 360 degrees. If the sectoral angles are computed correctly, the sum of the angles must be equal to 360 degrees. Example 4.8. Suppose the basic elements of cost of a restaurant are expressed as percentages of sales as follows. The arithmetic mean of ungrouped data. We compute arithmetic mean for both ungrouped and grouped data. We also compute arithmetic mean, which we henceforth in this unit call mean, for both the sample and the population from where the sample is drawn. Mean computed for the sample is called a statistic and it is denoted by x. The mean computed for the population is called a parameter and is denoted by u. The mean computed for the population is called a dash dash. Parameter. Any measure computed for the sample is called dash dash. Statistics. Any measure computed for the population is called dash dash. Parameter. The dash of ungrouped data is the summation of the values in the set of data divided by the number of values in the set of data. Mean. The mean of ungrouped data is the dash of the values in the set of data divided by the number of values in the set of data. Summation. For a sample the number of values is denoted by n, that is the sample size, and for the population size is given as n. Mean of ungrouped data, if a sample, is x. You are required to calculate the mean of the scores. To solve the problem, you should I. Multiply each score by its respective frequency to obtain fixie. 2. Add up the products of each score and its respective frequency to obtain sigma fixie. 3. Add up all the frequencies to obtain phi or n sigma. The arithmetic mean has the following advantages. I. Mean is the best known of all the averages. 2. Mean can be used for further mathematical process. Mean is used to perform statistical procedures such as estimation and hypothesis testing. 3. Mean is unique, unlike mode. Computation of geometric mean. For values xl, x2, x3, xn the geometric mean is the nth root of the product of the values. The geometric mean is denoted as gm therefore, where gm is geometric mean x1, x2, x3, xn are values of the variable of interest, while n represents the sample size. I. Multiply the values all together to get the product. 2. Take the nth root of the product. Example 6.1 What is the geometric mean of 3, 5, 6, and 7? Harmonic mean. Computation of harmonic mean for values xl, x2, x3, x. For this we do the following. 1. We add up the reciprocals of the values. 2. Divide the sum into the number of items. The dash is a measure that shows the most central item in a set of data. Median. Dash is a single value computed from the set of data that measures the central item in the data. Median. To calculate the median, there is a need to have a mathematical definition of the median. For an ungrouped data with odd number of values, the item in the middle constitutes the median. Example 7.1. What is the median of 17, 12, 13, 15, 18? These values are not arranged in any order. To find the median, we need to order the arrangement of the values. As 12, 13, 15, 17, 18. The value in the middle is 15 and that is the median. Using our formula for median. The advantages of median. I. The median cannot be influenced by extreme values as in the case of the mean since not all the values are involved in the calculation of the median. 2. The median can be calculated from incomplete records and for open-ended classes if the median does not fall into the open-ended class. 3. It is not difficult to recognize the median. The disadvantages of median. I. Median cannot be subjected to further statistical processing as it is with mean. 2. To compute median we need to order the values. This can consume time. Mode. Dash is simply defined as the value with the highest frequency in a set of values. Mode. Example 7.5 from the distribution below, find the mode. The mode is 8 because it has the highest frequency of 11. Suppose we replace the frequency of those in age of 10 years by 11, the distribution will have two modes, that is 8 and 10 respectively. Estimation of mode using histogram. Example 7.7. Using the table in example 7.6, Plot the histogram and estimate the mode. The mode obtained from the histogram is 40.0. This is a good estimate of the computed mode. Advantages of mode. It can be used as central location, just as in the case of median for both qualitative data too. Since its computation does not involve all the values in a set of data, it can be computed from an incomplete record and it is not influenced by extreme values as it is the case with mean. The disadvantages of mode. It is not as commonly used, as much as means are, to measure central tendency to. There may not be mode in a distribution if every value has the same frequency as others. 3. There can be many modes in a distribution resulting into a problem of interpretation. The dash shows the relative positions of the mode, median and mean in the distribution. Skewness. The dash measures the peakness of a distribution. Kurtosis. A dash is defined as the value of the item which is a given fraction of the way through a distribution. Fractal. Dash is a fractal showing the tenths of the way through a distribution. Decile. Dash are fractals that relate to the hundredths of the way through distribution. Percentile. A dash has a peak at the middle of the distribution with the slopes on the either side of the peak virtually equal to each other. Symmetry distribution. The dash of the skew depends on the relationship of the peak of the distribution to the center, mean, of the histogram. Direction. The direction of the dash depends on the relationship of the peak of the distribution to the center, mean, of the histogram. Skew. The direction of the skew depends on the relationship of the peak of the distribution to the center, mean, of the dash dash. Histogram. The dash of a distribution is the difference between the highest and the lowest values in a distribution. Range. The simplest measure of dispersion is called dash dash. Range. Example 9.1. What is the range of the following values? 2, 3, 5, 6, 8, 9, 11, 22, 34, range equals 342 equals 32. The dash is computed by taking the sum of the absolute value of the deviations of the values in the distribution from the mean of the distribution and dividing the sum by number of value in the distribution. Mean deviation. A dash is a collection of definite, distinct objects called elements or members of the set. The dash of sets A and B is a set of all the elements that are common to both sets A and B. Intersection. Dash is used to solve problems involving set theory. Venn diagram. Dash can be defined as an ordered arrangement of objects. Permutation. Dash is an arrangement of objects without regard to order. Combination. Dash is defined as a value between 0 and 1 that shows the likelihood of occurrence of an event. Probability. The probability that a man born of a woman will die one day is dash dash. 1 dash is a discrete random variable distribution in which one of the two possible mutually exclusive outcomes occurs in a trial or an experiment. Binomial distribution. Binomial distribution is derived from a process called dash dash. Bernoulli trial. Dash are used to solve problems involving probability of success. Binomial tables. A dash is determined by the values of delta and the standard deviation and mean of the population respectively. Normal distribution. The degree of asymmetry, or departure from symmetry of a distribution is known as dash dash. Skewness. A complete absence of skewness would have a coefficient of skewness equal to dash dash 0. The number of times that a variable occur is called dash dash. Frequency. The sum of the absolute difference between consecutive set of data xj and mean x of the data divided by the number of data is dash dash. Mean deviation. A particular value of the population, such as the mean income or the level of formal education, is called dash dash. Parameter. The two sources of data are dash dash. Primary and secondary. Any measure indicating the center of a set of data, arranged in an increasing or decreasing order of magnitude, is called a measure of dash dash. Central tendency. Scores that differ greatly from the measures of central tendency are called dash dash. Outliers. The total of all the observations divided by the number of observations is called dash dash. Arithmetic mean. The sample mean X is an example of a dash dash. Statistic. The population mean mu is an example of a dash dash. Parameter. The arithmetic mean is highly affected by dash dash. Extreme values. If a constant value is added to every observation of data, how would the value of the arithmetic mean behave? Increased by the constant. The median is considered a robust measure because it is resistant to dash dash. Outliers. What effect will the elimination of extreme scores at the bottom of a data set have on the mean? Dash dash. Increase the mean. The elimination of extreme scores at the top of the set has the effect of dash dash. Reduce the mean. The sum of deviations taken from mean is dash dash. 0. The sum of the squares of the deviations about mean divided by the number of observations is dash dash. Variance. If sigma I equals 110 she dash 50 equals 100, then sample mean X will be dash dash 60. For a certain distribution, if sigma X minus 20 equals 25, sigma X 25 equals 0, and sigma X 35 equals minus 25, then xi is equal to dash dash 25. The sum of the squares of the deviations of the values of a variable is least when the deviations are measured from dash dash. Arithmetic mean. If x dash equals 100 and y equals 2x, 200, then mean of y values will be dash dash. Zero-step deviation method or coding method is used for computation of the dash dash. Arithmetic mean. If the arithmetic mean of 20 values is 10, then sum of these 20 values is dash dash. 210 families have an average of 2 boys. How many boys do they have together? 20. If the arithmetic mean of the two numbers x1 and x2 is 5, if x1 equals 3, then x2 is 7 given x1 equals 20 and x2 equals dash 20. The arithmetic mean will be dash dash 0. The mean of 10 observations is 10. All the observations are increased by 10%. The mean of increased observations will be dash dash 11. The frequency distribution of the hourly wage rate of 60 employees of a paper mill is as follows. The mean wage rate is n dash dash 59.00. The sample mean x of first n natural numbers is dash dash n plus 1. 2. The sum of deviations is 0 when deviations are taken from dash dash mean. When the values in a series are not of equal importance, we calculate the dash dash weighted mean. When all the values in a series occur the equal number of times, then it is not possible to calculate the dash dash weighted mean. The mean for a set of data obtained by assigning each data value a weight that reflects its relative importance within the set, is called dash dash weighted mean. The arithmetic mean of 10 items is 4 and the arithmetic mean of 5 items is 10. The combined arithmetic mean is dash dash 6. The midpoint of the values after they have been ordered from the smallest to the largest or the largest to the smallest is called dash dash median. The first step in calculating the median of a discrete variable is to determine the dash dash array. The suitable average for qualitative data is dash dash median. If the smallest observation in a data is decreased, the average which is not affected is dash dash median. Sum of absolute deviations of the values is least when deviations are taken from dash dash median. The frequency distribution of the hourly wages rate of 100 employees of a paper mill is as follows. The median wage rate is n dash dash 59.00. The values of the variate that divide a set of data into 4 equal parts after arranging the observations in ascending order of magnitude are called dash dash quartiles. The lower and upper quartiles of a symmetrical distribution are 40 and 60 respectively. The value of median is dash dash 50 if in a discrete series 75% values are less than 30, then dash dash. Third quartile equals 30. The probability of the amount X, in million naira, of investment in the shares of ABC company is given as follows. Find E, X, dash dash. 35/18. The mean of first two n natural numbers is dash dash. 2n plus 1. 2 if x1, x2, x3, xk be the arithmetic means of k distributions with respective frequencies n1, n2, n3, nk, then the mean of the whole distribution xc is given by dash dash. Sigma nxn. Sigma. The combined arithmetic mean of two sets of means is calculated by which formula? n1x1 plus n2x2 n1 plus n2. Extreme scores will have the following effect on the median of an examination. They may have no effect. The probability of the amount X, in million naira, of investment in the shares of ABC company of Adewale is given as follows. E, x2, is actually 5.89. What is the variance of X? 2.11. The group frequency distribution shown below is to be used to answer the following question. Which class is the modal class? 20 to 24. The group frequency distribution shown below is to be used to answer the following question. Which class is the median class? 20 to 24. The group frequency distribution shown below is to be used to answer the following question. What is the cumulative frequency of the modal class? 14. For a standard normal distribution, what is the values of the mean and variance? Mean equals 0, variance equals 1. Given the set of numbers, 15, 16, 12, 11, 19, 18, 13, then xi dash. 1600. The mean of 63, 19, 52, 10, 95, 18 is dash dash. 42.83. The median of 63, 19, 52, 10, 95, 18 is dash dash. 35.5. The mode and the range of the above data are dash dash. 40, 40. The geometric mean of 6, 8, 10, and 16 is dash dash. 9.36. The harmonic mean of 6, 7, 8, and 9 is dash dash. 7.33. Given that the mean of a distribution is 160, the mode is 150 and the standard deviation is 25. Find the coefficient of skewness dash dash. 0.4. A set of sales from an outlet produced the following: 16, 14, 18, 10, 12. Compute the variance dash dash. 8. The coefficient of variation for data set whose mean is 10 and variance 100 is 100%. For a symmetric distribution dash dash. The mean, median and the mode are equal. Which statistics is found by summing all the values and dividing by the number of observations? The arithmetic mean. How would you describe the skewness of a distribution whose mean is smaller than the median? Negatively skewed. What level of measurement is required for the median? Ordinal. The Nigeria Stock Exchange, NSE, index increased from 961 in 1980 to over 9,500 in 2003. The annual rate of increase is best described by the geometric mean. What is the shape of a frequency distribution with an arithmetic mean of 12,000 pounds, a median of 12,000 pounds, and a mode of 12,000 pounds? Symmetric. Given that the mean of a distribution is 60, the mode is 50 and the standard deviation is 25. Find the coefficient of skewness dash dash. 0.4. A set of experimental animals was fed in a special diet for 1 week and produced the following gains in weight: 6, 4, 8, 10, 12. Compute the variance. 8. The coefficient of variation for data set whose mean is 16 and variance 10 is 19.8. Given the mean equals 60 and variance is 625, find the coefficient of variation. 41.7%. Suppose A and B are independent events with PA equals 0.2. PB equals 0.6 what? Is PAB equals 0.2 in a shipping organization? It is observed that the total number of items imported is 400 units. If you are to categorize these items into types of commodity with the aid of a pie chart, what angle would 160 units of chemical take? 144 degree. The data collected by questionnaires are usually classified as what type of data? Primary data.